Well, welcome back to Sushi Live Noding. While I have this my AR mask rendering in the background, I thought I might do a quick live noding. So it's Sverchok Add-On. Once again, it's got an update, and in the latest update, we actually have an ellipse node. So uh, let's take a look at these nodes. So what does this do? Actually, it will generate some kind of points and also edges and polygon that will generate ellipse. So that's the premise. It's really simple, really simple nodes to use, but really powerful as well. So let's explore these nodes. So ellipse nodes, it's got a bunch of options, parameters that you can study, you can try. The best way to look at nodes in Sverchok for all kind of generators, line, plane, whatever. If this is the first time you use Sverchok add-on, it's basically I recommend you to either use Viewer Draw or Viewer Bemesh. So these two will work. So one will generate real object in the 3D scenes right away that you can render. You can give material and then use light, etc. And of course you can change locations and then do all this. But the other one is Viewer Draw. I like to use Viewer Draw most of the time because it's I feel it's a bit faster, and also it's easy to see variations with this color. Okay, so let's get started. This is the default. You can see that there is like a major radius, minor radius, similar to others like what is that? Spiral also have. Oh, actually, Torus. Torus not has major radius and minor radius. So you don't need to like fully understand the terminology. You just need to understand what this thing actually does. So let's try it one by one. Major radius. Okay, you can kind of stretch the ellipse. You can easily get the ellipse. This is the important part. And if the major radius is smaller than minor, then it becomes a circle. With the minor, you cannot go stretch it too far. You can kind of squash. So one seems to be stretching, the other one is squashing. You cannot go too far, and if it's too big, then if it's bigger than the major, then you get a circle. It stops right there. But you can squeeze it until 0, and the other one you can stretch it, but it cannot. You can stretch, but you cannot squash it. I think that's how I think of it. Number of vertices, of course, that's the sampling. That's the usual. And you have phase. So this is cool. Just like a torus knot, you can do quick rotations this way. If you have an object like icosphere, for example, and then you kind of instance icospheres on those points of ellipse, when you increase the phase, it's gonna rotate. Oh, yeah, the phase, that's the phase, and the other one is the rotations. This is almost like kind of like the way planets will orbit around the sun, or how the moon, the star rotates around the planet, I guess. So you can easily make that. There's an example at Sverchok GitHub on the planetary kind of simulations. So this ellipse, of course, make it really, really easy. So there's a second one. Okay, you have major radius, eccentricity. All right, so it's kind of similar. And then we have this also, major radius and focal length. That's interesting. They're all very similar, but there's a slight difference maybe in terms of math formula being used. There is an interesting output here. F1 and F2. What are those? I don't know exactly, but just plug it into a viewer draw and then have a look. So apparently it's like a points. If I give it like this one, I'll give a red color, and this one I'll give it a green color. You can see the 2 dots there. Let me actually turn this into just edges. So F1 and F2 seems to be like what are those? It's like I forgot the math name for it, but I think it's 2 dots that were is at the center point of the ellipse. I don't know what's the exact terminology, but I think that's the 2 points that influencing the force so that it make the circle become an ellipse, I guess. So as I'm kind of playing around it with major and minor radius, we can see the 2 points are there, and we can change the position, the center into either the center or F1 or F2. So that's, I guess, what this node is doing. So if let's say if you ever want to do like a kind of like a planet kind of motions or movement around the ellipse, you can use the phase and the rotations. So let's try that. So that's the orbit path. That's the center. Okay, we turn off the center. Let's create another viewer draw. And here we can have Susan. Susan, maybe just Susan face, and then we want to rotate Suzanne based on one of these ellipse points. So we're gonna use list item, get one of the vertices, plug it into this guy. So it's gonna be the locations for Suzanne. So this matrix. And if we rotate, if we are using the phase, then Suzanne's gonna rotate around the ellipse. So let's do that using a frame. Plug into the phase and then math multiply by 0.1. So that's doing what it does supposed to do, and we can put Susan head there. And yeah, so it seems to be working, and not sure if you want to also do these rotations. Maybe you don't want to do that, but for sure you also want Susan head to rotate around itself. So for that we can try. So rotation, let's see if I'm rotating this guy. Yeah, seems to be rotating Susan head. So let's try that. Frame multiplier, plug into the rotations, increase the number of multiplier, and then Suzanne should be rotating as well. So that's starting to look a bit like planet orbit. It's rather fast, but yep, it's doing its job. And you can easily have multiple variations of this, and then while you still have control over the minor and major radius. And on top of this, if I'm not wrong, you can also, you probably want to deform the orbit as well. So matrix deform probably can do the job. There are many ways to do this. I think this is one of the easiest that seems to be making sense for me. Oh, actually, this doesn't seem to change the rotations. Oh, that's interesting. Wonder why. So we have Suzanne, we have this matrix. I am Let me try scaling it. Oh, that's actually scaling Suzanne. So that's wrong. Oh, the angle of Suzanne seems to be different, but the actual orbit is the same. So that's definitely wrong. What I probably need to do is to rotate the orbit from here. So rotate. And yep, I think I did rotate the curve. If we want to visualize the dots, let me try changing it. Okay, I'm changing it to dot line and do the rotations of the orbit. So that's a little bit better. All right, so that's planet doing its orbit. I think in order to do this properly, then I might need to do a little bit of research on how planets is actually rotating around. But I think this is kind of doing its job. So I can rotate in whatever I like. And let me check. Axis, angle. Sometimes you actually want to have the axis and randomize the axis this way, so you can have easily different orbit rotations, and at the same time you also want to have different planets. So currently we only have a single Susan head doing the rotations, but you get the idea. If we have random vector plug into the axis, we should have like a different result. But I think we might need to have a monad for this. So don't do everything in one go, otherwise it's going to be so confusing. It's a good idea. So we have one planet rotating around using its orbit, the ellipse orbit. And so if you ever want to have multiple planets, don't just keep adding data here, but just the easiest way I think is to turn this into a single monad, and then from there you can have multiple planets. You will end up with 9 monads, but it's gonna be a lot easier to handle. So yeah, so that's a quick look at Ellipse. If you want, maybe at some point I can turn this into a monad and then really work on that idea. But I think this is kind of interesting, very interesting. Nodes. It's a basic one, but it's needed. And if you ever need an ellipse, we got an ellipse. If you ever need others like torus node, we got plenty already here. So there you go. Thanks again for these notes to Sverchok developer. I highly appreciate, and thanks again. If you have any question, feedbacks, let me know, and I'll see you next time. Thank you. Bye.